In today's tutorial, we'll create a scene with an inverted, twisted torus. The focus here is going to be on building the scene, so we aren't going to get into the theory and mechanisms involved. If you're interested in that stuff, check out the videos in the RayTK intro series. We'll be using RayTK version 0.32, so make sure you're using at least that version. Check the video description for a download link. Start by dropping the toolkit docs into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you want. First, we'll set up the renderer. Open the palette with the Alt-R shortcut and create a RayMarch Render 3D. Then create a null top connected to the output so you can see the rendered image. Select the renderer and open RayTK's Editor Tools menu with Alt-Shift-R. And then under Add Camera, choose Look at Camera. On the camera, increase the FOV angle to 100 and set the position to 0, 10, and 8. We'll be replacing this camera later on, but we'll use it initially to get a better view of the shape that we'll be building. Select the renderer again and open the Editor Tools with Alt-Shift-R. And then under Add Light, choose Point Light. On the point light, change the position to 1, 2, and 3. The shape that we'll be building will be kind of like a torus, but instead of just using a torus SDF, we'll take a 2D shape and revolve it around the y-axis, which gives us more control over the shape. So we'll start by creating the 2D cross-section shape. Open the palette again and create a star SDF 2D. To get a better view of what's going on, we'll visualize the cross-section shape with the 2D renderer. With the star SDF 2D selected, open the Editor Tools menu with Alt-Shift-R and choose Colorize 2D SDF. Then, with the Colorize selected, open the Tools menu again and choose Add Render 2D. And then add a null top connected to the first output on the renderer so you can see the rendered image. On the Render 2D, decrease the zoom to around 0.25. Then on the star SDF, increase the radius to 2 and the points to 10. Next, we'll round out the shape a bit by combining it with a circle. Create a circle SDF. Then select both the star SDF 2D and the circle SDF. And open the Editor Tools with Alt-Shift-R. And then under Combine SDFs, choose Smooth Union. And then connect the Combine to the Colorize SDF 2D. On the circle, increase the radius to 1.7. Then on the Combine, increase the blend radius to 1. And that's our cross-section shape, although we'll make a few adjustments later. Now that we have the cross-section shape, we'll turn it into a 3D volume. Create a Revolve operator. And connect the output of the Combine to its first input. And then connect the output of the Revolve to the first input on the renderer. On the Revolve, change the axis to Y. Next, we need to spread it out since it's currently all at the origin position. So increase the radial offset all the way up to 4.5. And this gives us our torus-like shape. Rather than just viewing this shape as it is, we'll flip it inside out and view it from the inside. Create an invert operator and we're going to insert that between the Revolve and the renderer. This operator swaps the inside and outside areas of an SDF. Everything went dark because our camera is now technically inside the shape. We'll keep the current camera as it is so we can use it to examine the shape, and instead we'll add another one. Select the renderer and open the editor tools with Alt-Shift-R, and then under Add Camera, choose Fisheye Camera. Now we can see the inner area. The fact that it's a fisheye isn't what made it work, though. It just helps give a wider view. We can see things because the default camera location at 0, 0, and 5 happens to be inside the area. If we were to increase the Z position past around 6.5, it will go dark again because we'll now be inside the area. So let's go back to a position of 0, 0, and 5. On the fisheye camera, decrease the aperture a bit to around 0.2. This gives us a fairly wide view without making the central column too small. For now though, let's go back to our exterior view. Connect the old look at camera back to the renderer. And then go to the invert, and you're going to switch that off. The next step is to add some twisting. We'll do that by rotating the star cross-section as it revolves around the axis. Create an axis rotate operator and set the axis to Z. Then insert that between the star SDF 2D and the combine. Axis rotate is a simplified version of the rotate operator that only rotates around a single axis. We're using it in a 2D context here, but we do still need to tell it to go around the Z-axis. Try adjusting the rotate parameter and see how it shifts the pattern of the star kind of across the cross-section of the torus. What we want is to have a variable amount of rotation, depending on how far around the axis we are in the revolve. To do that, we first need to access the angle around that axis. Select the Revolve operator and open the Editor Tools menu with Alt-Shift-R, and then under Reference Variable, choose Normalized Angle. This gives us the angle scaled to a 0 to 1 range, though in some versions of the toolkit, like 0.32, there may be a bug that makes it go from 0 to 0.5 instead. We'll address that momentarily. Create a wave field operator and connect the variable reference to its first input, the coordinate field input. Then connect the wave field to the second input, the rotate field input on the axis rotate operator. Because we're dealing with angles and degrees, we'll need larger values than the default -1 to +1 range that the sine wave produces. So on the wave field, increase the amplitude to 50. If the version of the toolkit that you're using has the angle bug, you'll see a discontinuity in the left side here. If that's the case, on the wave field, decrease the period to 0.5. You should end up with something like this, where there's no discontinuity anywhere around that axis. Next, we'll increase the number of times that the wave repeats around the axis. One option would be to use a smaller period, like 0.125 or 0.25. As long as it's an even division of an integer, it should line up correctly as it goes around. Another option is to multiply the values that are coming out of the variable reference. Select the variable reference operator and open the editor tools with Alt-Shift-R, and then choose Rescale Field, and make sure to use that and not Rescale as vector. And then connect the Rescale field to the coordinate input on the wave field. On the Rescale field, increase the multiplier to 2. As long as this is a whole number, the wave will wrap cleanly. So you could go 3, 4, 5. But if you were to have a fractional number, you get a discontinuity on the left side there. Try adjusting the phase parameter on the wave field to shift that twist pattern around the center axis. We'll add some animation to this later on. The next step is to add some ridges across the swirl. We'll do that using the star SDF's tightness parameter. To make things easier to see, go to the combine and switch it off so that we're just using the star. On the star SDF, try adjusting the tightness parameter and see how it pulls those inner points either inwards or pushes them outwards. We're going to vary that parameter around that center axis, similar to how we're doing the twist. Copy the variable reference, the rescale field, and the wave field that we're currently using to control the twisting, and paste a new copy of those. Connect the wave field to the star SDF's tightness field input. And then on the wave field, decrease the amplitude down to 0.2. We'll end up reducing this even more later to make it more of a subtle effect, but for now we'll keep it at 0.2 so we can see what's going on a little bit better. Go to the rescale field where we're multiplying the coordinates that are feeding the wave. And we're going to increase the multiply setting to 10. So we now get 10 repetitions of the wave going around the center axis. Right now it's using a sine wave, which is a bit too round for what we're going for here. Something sharper would be better. On the wave field, try changing the wave type to square wave. Now this does give us a sharper pattern, but if you zoom in close, you'll see some render glitches around those boundaries between the two different values. The values are changing too rapidly over too short a distance here, which is confusing the ray marcher. So what we want is something that's like a square wave, but gives us more control to smooth it. The wave field operator itself doesn't have that kind of wave built into it, but it does have an input that lets us specify our own type of wave function. Create a pausing wave function operator. And connect that to the wave function input on the wave field. On the pausing wave function operator, click the inspect parameter to open the inspector tool so we can visualize the shape of the wave. This operator is like a square wave, but with smooth transitions between the low and the high parts. The two parameters control the width of both of the sections, the low part and the high part, and the remaining area is filled in with smooth transitions. Note that if you change the width parameters so that it kind of inverts beyond what fits in a single repetition of the wave, it will invert the wave, but let's avoid doing that. Set the width for the low part to 4 and the width for the high part to 3. This gives us a wave that is mostly at the high value, but dips down to these low kind of indents with a smooth transition in between. Close the inspector. Now if we look at the shape, we can see how we get those periodic kind of areas where it bumps up a little bit. We get stripes that are similar to with the square wave, but with a smooth transition between the two parts. We've now set up all the elements that are needed to define the shape. We just need to fine-tune things. So let's go back to the inside view. Switch back to the fisheye camera by connecting that to camera input on the renderer. Then go to the invert, and we're going to switch that operator back on. Now we're back on the inside of the shape. So we want to squash the wave that's controlling the star tightness down so that it's more of a texture than a change in shape. On the rescale field for the wave that's controlling the tightness, we're going to increase the multiplier up to around 150. Then on the wave field, we can decrease the amplitude down to around 0.03. And then increase the offset to 1. This gives us values that go from 0.97 to 1.03. Go to the combine operator that's combining that star with the circle and switch that back on. You can use the blend radius setting on the combine and the radius on the circle to control the shape of the surface, make it either kind of rounder or give it harder edges. But I'm going to keep it on that value of 1.7 for the circle radius and 1 for the blend radius on the combine. Next, we'll set up the material. Create a modular mat, and we're going to insert that between the invert and the renderer. With the modular mat selected, open the Editor Tools menu with Alt-Shift-R. Under Add Diffuse, choose Orin Nair. Select the modular mat again and open the Editor Tools menu, and then under Add Specular, choose GGX. On the diffuse contrib, choose a color. I'm going to go with sort of a light desaturated orange to give it a little bit of a copper look. Then increase the roughness and albedo both to 1. Then go to the specular contrib, choose another color. I'm going to go with a light blue. And then increase the roughness to around 0.7. Next, we'll move the light to get a better mix of the specular and diffuse. Right now, we're mostly seeing the diffuse with a little bit of an area of the specular in the middle on the bottom. So let's go to the point light, and I'm going to increase the X part of the position up to around 8. And then increase the Y also to 8. And then for Z, I'm going to put that to 4. So this placement gives us a nice large area with more of the specular, as well as an area with more of the diffuse. The last step is to add our animation. We'll be animating the 2 waves that are controlling the shape and the cross-section rotation. Go to the wave field that's controlling the tightness of the star. Select that wave field and open the Editor Tools menu with Alt-Shift-R, and then under Animate with Speed, choose Phase. We'll leave this at the default speed of 1. Since the size of the wave is really small, having it at a higher speed doesn't actually cause it to move that fast in the scene overall, so it's fine as it is. Select the axis rotate that's twisting the cross-section as it goes around the axis. While we are using a field to control the rotation, this operator also lets us add in the rotate parameter to rotate this by the same amount everywhere. So select the axis rotate and open the Editor Tools menu with Alt-Shift-R, and then under Animate with Speed, we're going to choose Rotate. And because we're dealing with angle values here, we're going to want larger values that increase faster. So on the speed generator, increase the value multiplier to 30. And then drop the speed multiplier to around 0.3. Then select the wave field that's controlling the twisting around the axis. Open the Editor Tools menu again, and under Animate with Speed, choose Phase. And on the speed generator, drop the speed down to around 0.07, and then switch on reverse. And that's it for our scene. To recap, we're creating our own torus shape by revolving a 2D cross-section around the y-axis. The cross-section is created by combining a star SDF and a circle using the smooth union mode. We're then twisting the shape as it goes around the axis using an axis rotate operator controlled by a wave that's based on the angle around the axis coming from the revolve. We're also modulating the tightness of the star using a similar pattern using a wave, using the pausing wave shape, going around the axis, again using the angle from the revolve. Then we're inverting the whole thing and using a fisheye camera placed inside the area to get a wider angle view from the inside. And we're using a modular material with a diffuse and a specular element using different colors to give it some more color variation over the space. And finally, we light the scene using a point light position so that we get some areas where the diffuse is dominant and some areas where the specular is dominant. If you want to expand on the scene, some potential areas would be to experiment with the balance between the circle and the star, using either the blend radius on the combine or the radius on the circle, or both. You could even use a field to control the blend radius, similar to what we're doing for the cross-section rotation here. You could also try varying the radial offset on the revolve using a similar field. And that would give you shapes that are kind of more irregular than just like a straight circular torus. You could also try swapping in different types of 2D SDFs as cross-sections. And that's it for today. Check out my Patreon to support RayTK development. You'll get early access to tutorials, exclusive scene downloads, and more. Thanks for watching, and as always, make sure to like and subscribe.